Okay, the next one we will talk about the DC motor. DC motor take the electrical current from the supply and then produce a rotating force. So this is DC motor. So that we can calculate the force. The force produced by the DC motor is PIL. B is a flux density, I is a current, and A is a length of the conductor. Where the conductor carrying conductor is under the influence of the magnetic field, the conductor will be forced to move. This force is magnetic force. This is for the electromagnetic force. This electromagnetic force can be calculated by equation. This is the BIL. B is flux density, I is a current, and the A is a length of the conductor. This is the way we can calculate the force on the motor. So the F is the force, Newton meter. And here is a flux density, Tesla. I is current, units ampere. A is a length of the conductor. Unit meter. So this is the way we can calculate the flux. So that based on here, we saw the one problem. This problem is given a 150 millimeter long conductor carry the 40 ampere at a right angle to magnetic field with flux density 0.5 Tesla. We need to calculate the force acting on the conductor. So the conductor length is given the 150 millimeter. So 150 multiplied 10 power minus 3 meter. Current 40 ampere. Magnetic field flux density 0.5 Tesla. So that we can calculate the force. Force equal to BIL. So B is 0.5 Tesla. Current is 40. And A is 150 multiplying 10 power minus 3. So the 10 power minus 3. So we can calculate. So 0.5 multiply 40 multiply 150 multiplying 10 power minus 3. So we calculate. That way we can calculate the force. The 0.5 multiply 40 multiply 150 divided by 1000. So you got that will be the 3 Newton. The force is 3 Newton we got. The next problem. Determine the increase of the flux density required to increase the force to 7 Newton. In this case, our force is given as 7 Newton. The current is unchanged 40 ampere. Length of the conductor is also 150 millimeter. We need to calculate the flux density. So that we calculate F equal to BIL. Then B equal to F by IL. The force is a 7. The current 40. Length of the conductor is 150 multiplied 10 power minus 3. So we calculate that 7,000 divided by 40 divided by 150. So we got that will be the 1.166 Newton. Tesla. So in this case, increase. How many increase? So originally the 0.5, so the 1.166 minus 0.5. So we got this here. That will be the 0.66 Tesla. So this is the flux densities are increased when we calculate it. The next problem. The armature has a radius of 125 millimeter. Conductor length is 150 millimeter. Under the FIBO, the infra is 0.4 Tesla. Armature current is 100 ampere. So we have to calculate the force acting on the conductor. And also we need to calculate the torque. So the conductor length is 150 millimeter can be calculated. So in this case, our conductor length is given the 150 millimeter. So 150 into 10 power minus 3, so you got the 0.15 meter. This is the conductor length. Flux is 0.4 Tesla. V equal to 0.4 Tesla. Armature current 100 ampere. I equal to 100 ampere. We need to calculate the force. So force can be calculated VIL. Flux density multiply current multiply length. We can calculate the force. So in this case, we substitute here. Flux density is 0.4. Current 100. Length of the conductor is 0.15. Then we can calculate here is a 6 Newton. Force will be 6 Newton. So the force is on the radius. This is force. The radius is 125 millimeter. Here is 125 0.125 meter. So torque can be calculated 4 multiplied radius. The force is 6 Newton. Radius is 0.125. So that will be 0.75 Newton meter. Torque can be calculated 0.75 Newton meter. So this is the answer. The next problem. In armature with the radius of 125 millimeter, one with the 4 coil. So this is the armature. The radius is 125 millimeter. One with the 4 coil, each got the 100 turn. Affecting on the 1/2 of the loop under the people is 200 millimeter. So that there will be the affected is a 200 millimeter. So there will be one coil is every 1 turn 200 millimeter multiplied 2. This is the 1 turn. How many turn? 100 turn. So this is for the 1 coil. 1 coil, every 1 turn is a length of the armature 200 millimeter. So that there will be go and return. There will be the 200 multiplied 2. Every 1 turn is a 200 multiplied 2. So there are how many number of turns? 100 turns. So the every coil, this is the length of the heavy coil. Every coil. So how many coils together? There are 4 coils. So therefore we can calculate the total length of the armature conductor is 400 multiply 100 multiply 4. This is and also we need to calculate the convert to the meter. So multiply 10 power minus 3. So here we can get 160 meter. So this is the length of the conductor we calculated. Then we also need to calculate the torque. So the firstly you have to calculate force. Force will be VIL. Flux density multiply current multiply length of the conductor. In this case, flux density given as 0.2 Tesla. The current is given the 250 ampere. Length of the conductor 160. Then we can calculate the force. Y2 multiply 250 multiply 160. So you got the 8,000. 8,000 Newton. Then we can calculate torque. F multiply radius. So 8,000 multiply radius 125 millimeter. So multiply with 10 power minus 3. So 8,000 multiply 125 divided by 1,000. So you got 1,000 Newton meter. And we also calculate another problem. A DC motor has a machine constant 20. Main ply is a 0.015 Weber. right at the 750 meter. We need to calculate EMF generated with armature conductor. So in this case, back EMF can be calculated. Back EMF is the same. 5 multiply and multiply machine constant K. Similar to the generated EMF. Generated EMF for the generator, back EMF for the motor. In both cases, 5 multiply and multiply machine constant. This is the way we calculate the back EMF. So in this case, the machine constant is 20, flat is a 0.015 Weber, and run at the 750 RPM. So we substitute. First can be calculate is substitute is 0.015 Weber, RPM 750. Machine constant is 20. So the 0.015 multiply 750 multiply 20. So that will be 225 volts. The next problem. A DC motor has a machine goes, and if the motor connected to 250 supply, so that this motor connected to the 250 volt supply, armature current is a 0.15 ampere. So we have to calculate the amount of current. So in this case, the machine constant, this is the EV here, the armature this is RA, and connected to the supply VD. So in this case, this current is flowing to IA. So we write down the equation VD equal to EB plus IA multiplied IE. So that's the equation. So the terminal voltage is given the 250 volt supply. EB is 225. We need to calculate the armature current. Armature current unknown. Armature resistance is 0.15 ohm. So that we can calculate 0.15 IA equal to 250 minus 225, so you got the 25. IA value is 25 divided by 0.15. So 25 divided by 0.15. So that will be the 167 ampere. Then the next problem. This motor is an equivalent circuit for the DC motor given. Here is a DC supply. So this is a DC supply here, positive and negative. Here with the P winding. P winding. P winding is given. And here with the armature circuit. Armature resistance RA and armature generator back here is a EB. Then here we connected to the terminal voltage VT. So this is for the DC motor connection. So firstly, we have to calculate the back EMF. So in this case, the flux phi, the machine flux is 0.0125 Weber. Run at the 250 RPM and equal to 250 RPM. Machine constant K equal to 8. So we have to calculate back EMF EB. EB equal to phi n into K. Phi is a flux, n is a RPM, K is a constant. So in this is flux value is 0.0125. RPM 250, K is at 8. So we substitute 0.0125 multiply 250 multiply 8. So you got the 25 volt. Per EB 25 volt. Then we also need to calculate the armature current. In this case, the supply terminal voltage 28 volt. So armature resistance RA is 0.1 ohm. So we write down the equation. VT equal to EB plus IARE. VT is a terminal voltage, EB is a back EMF, IA is the armature current, RA is the armature resistance. Both you have to substitute. In this case, our VD terminal voltage 28 volt, EB is at 25. We don't know that RA value is at 0.1. So we substitute so that IA multiplied 0.1 equal to 28 minus 25. So this is the 3. So IA can be calculated 3 divided by 0.1. So you got the 30 ampere. So this is the IA we calculated. We also need to calculate the torque. Before you calculate the torque, we have to calculate the force. Force you need a VI into L. That will be the force equal to VIL. So this is the VIL, or alternatively, machine power Y equal to 2 pi ND by 60. So there are two calculations we can calculate. So the power, what is equal to terminal voltage multiplied current. So this is the power. So that we substitute terminal voltage 28 volt. Current is the 30 ampere. This is equal to the 2 pi NT by 60. So the T can be calculated 28 multiplied by 30 multiplied by 60 divided by 2 pi M. So 28 multiplied 30 multiplied 60 divided by 2 multiplied 3.14, and now the machine rotating at the speed 250 rpm. Then you can calculate the torque. So that will be the 28 multiplied 1800 divided by 6.28 divided by 250. So you got the 3 Newton meter. That will be 32 Newton meter. And armature voltage for VA can be calculated. That will be IA into RA. So IA is 30, RA is 0.1, so you got 3 volt. So those are the answer.